Bismillahirrahmanirrahim. Assalamu alaikum. I am trying to give you the lecture by recording the lecture using a software, and this will create the video file. So I am going to upload the video file, and you can listen, you can see the video, and you can listen my voice. Maybe it is going to be helpful for some of the students who want to listen and they want the more explanation. I already uploaded this lecture as a PDF and PowerPoint file, and many students can read the lecture, and the contents of the lectures are not very difficult. So either you watch the video or you read the lecture slide. The contents are the same, but of course in the video lecture you will find my voice and explanation of these things. So you can use both of them or you can use any of them. There is some accompanying software there which I will try to demonstrate you how you are going to run this software. So let's first start the lecture, and in this lecture we are going to talk about the motion capture. Motion capture means that we are capturing or we are recording the motion of the human beings, and then this motion can be used for the different purpose. For example, we can use this motion to apply to animate the cartoon characters which are being used in the games and in the movies. So this is some of the application for the motion capture data. Let's see what are the content for this lecture. We will discuss about the some information how the motion capture data is being recorded, and then some kind of technical terms which are being used to describe the motion capture data. For example, the degree of the freedom and the skeleton and the bone, because I said that we can apply the motion capture data to some cartoon characters or some other animated characters, and these characters have the skeleton and the bone. Then finally we are going to discuss about the BioVision Hierarchy BVH file format. So like for the images, we are saving the image in a different format: JPG, BMP, PNG. These are the format to save the image file. Similarly, we have a file format which is used to save the motion capture data. So we will see about this thing. Let me see that if my recording is going correct. Yes, so this is the software I'm using for the recording, and you can see that this is 2 minutes 56 seconds. So let's come back to the slide and see that what are the things we want to discuss in this lecture. So the first thing is the motion capture. Here you can see on the right side we have a picture in which we have the human being is there, and this human being is going to perform some motion, some action, some movements, and by using the cameras and the markers we are going to record these motions. For example, you can see here that these are the cameras are there, video cameras. They are being in the different location in the room where the motion capture session is being recorded. Usually we have 8 cameras are there which are recording the motion of a person, and this person is wearing a cloth in which they are the markers are there. These markers are attached to the clothing of the person, and they are recording the movement of the person. So whenever the person is moving the hand or moving the legs or whatever the body part where the markers are attached, the motion data is being recorded. The motion data means the translation along the x-axis, y-axis and the z-axis, and the rotation around the x-axis, y-axis and the z-axis are being recorded, and we are going to save these movements in a file. And please, it is very important that when we are recording the motion, we are recording only the translation and the orientation or the rotation. We are not recording the appearance of the character. So the meaning is that the clothing, the color of the cloth, the person appearance, his face, these are not being captured like a normal video camera. we are only recording the movements. So I will try to show you some video, but let's complete this thing. Motion capture record only the movements of the character, not his her visual appearance, as I say that. So whatever clothing you are wearing, it's not important, only the motions or the movements are being recorded. And almost all the game use the motion capture to drive the character animation. The meaning is that, for example, if you are playing the video game like a FIFA or some Xbox game, so in which you are controlling the character, and by pressing certain keys the characters are moving. So when the character do some action, or the character is walking or jumping or running, so these movements are being shown by the motion capture data. So the capture data which is being obtained from the human beings, and they are being applied to the animated characters. So when the character is jumping, basically this is the jump of the human being which is in applying to the motion capture data. So let me try to show you a video file. Let's see, motion capture. I'm opening the folder, and here this is a video file which is showing the motion capture session. In this file you can see that two characters are there. They are playing the soccer, and markers are being attached, and the cameras are there. So you can see that here is the camera, here is the camera, here is the camera. So they are recording the movement of these persons. So they are being recorded in a file, and of course there is a computer which is connected with this camera to record the movement of these persons. So these are doing the different actions, and they are being recorded, and you can see the markers being attached to this person. Now the movement of these persons are being applied to some character. You can see that they are the two football players are there. So the motion which is recorded for the human being is being applied to these characters. So they are playing the football, and they are doing the same action. So if you are applying these motion capture data to these characters, they can do the same movement as the character is doing. But in case for the game, we have to do the more programming so that we can control the action of the person. But of course these movements either you are using in the videos, in the movies, or you are using them in the games. They are being using the motion capture data. So this is the thing, you get the idea that what is basically the motion capture. This is basically the motion recording. So now let's see some terminologies about this motion capture data. The first thing is the degree of the freedom. Degree of freedom are the set of independent displacement and or rotation that specify complete the displaced or deformed position and orientation of the body. The meaning is that when a person is moving his body part, for example his hand, so he can perform some movement. He can move the hand from left to the right, from down to the up, and he can rotate maybe 30 degree, 40 degree. So these are called the degree of freedom. But one thing is important, that we have a limitation for the degree of freedom. We do not have the degree of freedom for every joint to rotate like a 360 degree. For example, like a neck, what do you call in Darby? Onok, I think. So you cannot rotate it 360 degree. Maybe you can rotate on the right side 180 degree and the left side 180 degree, maybe somewhat closer to that, but you cannot rotate it 180 degree. And similarly, some joints can rotate about the around the x-axis, but they cannot rotate around the y-axis or the z-axis. And some joint can rotate about the y and the z-axis, but they cannot rotate about the x-axis. So there are some limitations are there in the human body, how much rotation they can perform and what translation they can perform. So this is the degree of freedom. Now the maximum degree of freedom is the 6. Why the 6? We can perform the 3 kind of translation around the 3 axis. Means that we can perform the translation. Translation means moving along the x-axis. We can perform the translation around the y-axis and the translation around the z-axis. So this is the maximum. But maybe we can limit this thing to that somebody can translate around only the x-axis. Y and z are not changing. So in that case, the degree of freedom for the movement will be 1. if the body can move around only one of the axis, but maximum it is 3. And similarly we have the 3 degree of freedom for the rotation. A body can rotate theta x, that is the rotation around the x axis, theta y, rotation around the y axis, and the theta z, the rotation around the z axis. So this is the maximum, but I told you that there can be some limit. For example, a body can rotate about the x axis between the minus 180 and the 180, for example like a neck. So there is some limitations are there, and maybe a body like a neck cannot rotate around the z axis, so there are some limitations are there, but the maximum degree of freedom for any joint can be the 6. 3 are the movement translations and 3 are the rotations. So this is the degree of freedom. Now let's talk about the another terminology which is used in the motion capture data, and this is called the frame. What is a frame? When you talk about the video frame, you mean that you have a complete image is there. For example, your video may consist of 100 frames, 100 images, but in the case for the motion capture, this is not actually the images. These are the complete set of poses for all the joints, which are making a complete picture of the character, his motion, that is his rotation and the translation. Then this is called the frame. So in the complete frame for every joint, we will have some translation value and we will have some rotation value. We are going to call this thing as a frame. Even the joint is not moving, he is just standing, but still we have to save these value for every joint where the markers are being attached. When I talk about the joint, what I mean that when we attach the markers, we attach the marker to the joint, because usually we can move the joints. For example, here you can see that this is like a elbow joint. So this joint can perform some rotation and some translation. So when we talk about the frame, we have to store, we have to record the translation and the rotation value for all the joint, not only for one joint. Let me elaborate you this thing more. Let me discard this thing. For example, let's see, open this thing, open the new file. So for example, there is a joint one is there, this may be the elbow joint. We have to store the translation value x, y and the z for this joint, and we have to store the rotation value. For example, I share rotation about the x axis, rotation about the y axis and the rotation about the z axis. This is the possible set of value for the joint 1. Similarly, we are going to store the values for the joint 2. Similarly, we are going to store the value for the joint 3. When we have store all of these value, then this is going to be called the complete frame for one instant. But of course the body is moving, so we have to record this thing for all the joints. For in 1 second we are going to record this thing maybe around 60 times or maybe around 120 times. So we have to record these value if the n joints are there n time. So this is going to be the frame 1. Similarly, we have to record these value for the frame number 2. Again, for every joint, either it is moving or not, we have to store these value. This is going to be the frame number 2, and these things will continue for all the frame we want to record. So this is going to be continued. For example, if we are recording, let's suppose that 60 frames per second, so there are going to be the 60 frame in 1 second we are going to record. So you can see and you can imagine that we are recording this data very with the high frequency, and lot of data being generated, maybe 60 or 100 frame in just 1 second. And if you are recording the movements for 1 minute, and we are recording with the rate 60 frame 1 per second, then for the 1 minute they are going to be the 60 multiplied by 60 frames, which is going to be 3600 frame in 1 minute. So this is going to be recorded now, but this is the, you can say that the maximum values we are recording. But as I say that every joint may not perform the rotations or may not perform the translation, so the value is going to be remain the stationary. So this is what is mean by the frame. So a lot of data is being generated for these frames. Now let's come again, make it bigger. Now let's talk about that. When we record this data, we have to move our characters, cartoon characters or other character using this data. So we are going to talk about some terminologies which are called the skeleton and the bone. So first let's see the diagram so that you will have the concept what is a skeleton. On the right side you can see that we have a skeleton, and this skeleton has the many bones are there. For example, this is a one bone and the bones are connected with the joint, and this is a joint. Then this is the second bone and we have the joint. Then we have another bone. So we have to define the skeleton of a character on which we have to apply our motion capture data. Usually the human body is asymmetric. So if we have a three bones are there on the right side, then we will have the three bones there on the left side, and we have the joints are there. And these joints are the same joints where we attach the markers to record the motion capture data. And these joints are being organized in a hierarchical way. So on the right side you can see that we have a hierarchy of the joint. For example, at the highest level we have the hip joint, then we have a chest joint, then we have a neck joint, then we have the head joint, then the left collar, left arm up. What mean by the hierarchy? Hierarchy means that some joints in the hierarchy at the higher level and some joints in the hierarchy at the lower level. So what will happen when these joints are being arranged in a hierarchical way? When the joints at the higher level is performing some translation or some rotation, then the joints, all the joints which are in the hierarchy at the lower level, for example like these joints, they are going to be also perform the translation, because if the higher joint is moving, they are going to move automatically. But vice versa, opposite is not there. If some joint is moving at the lower level, for example like this head joint, the joints at the higher level hip, they are not going to be moved. So by this what we can do, we can move or we can rotate this part without affecting the other part. Let me again erase this thing so I can better explain you. Oh sorry, I should, maybe I will not save this thing. You have to bear with me because this is the first time I am trying to teach you this thing. So maybe sometime I will do some mistakes, so but you have to be bear with me, you have to be patient. So what it means? It means that for example if we are moving the joint at the lower level, this is at the lower level, then the joints at the higher level, they are not going to be affected, they will remain at their own position. But if we are doing the opposite way, what means? We are going to perform the rotation of the joint at the higher level. For example, if we are moving this joint, then this joint and the corresponding bone, they are going to move automatically because they are at the lower level. So the higher level can, movement of the higher level joint can affect the joints at the lower level. So this is a concept about the skeleton. Skeleton consists of the bones, and the bones are being connected by the joints. A skeleton is a whole character on which the motion data is applied. So actually we have to move this skeleton to create the animation. A skeleton is comprised of the number of bones. A bone represents the smallest segment that is subject to individual translation and or rotation changes during the animation. Bones are usually organized in a hierarchical structure. As we have seen in this diagram, we have the names of the bones are there, and they are being organized in a hierarchical structure. And as I told you that this hierarchy have the property that higher level joints controlling the lower level joint. Now let's talk more about the skeleton animation. Again, the purpose is the same. We record the motion capture data and we are applying this data to some other character, recording from the humans and then applying to some artificial character which are being created in some software. Some software means that, for example, there is a software like a Blender There is a software like a Maya, there is a software like a motion builder, in which you can create the character and you can apply the motion capture data to these character. Of course you need the motion capture data. Now how you obtain the motion capture data? As I told you that we can record this data. So one possibility is that we have a complete system, we have the markers, we have a cameras are there, we record this data from the humans and we apply to the artificial character which are developed in some software. The second possibility is that we do not record the motion capture data, but we obtain from somewhere which is already being recorded. So there are numerous sources of the motion capture data which are available on the internet. We can download this data and we can apply to some skeleton character, which we try to explain to you and try to demonstrate to you. Skeleton animation is the standard way to animate the character. A character is represented in the two parts: a set of bones called the skeleton or the armature used for the animation. So when we apply the motion capture data in the skeleton animation, we have to create the skeleton, and this skeleton will consist of the bones and they are being organized in a hierarchical structure. And the second thing is that we have a polygon mesh model or the character called the skin, because it does not look good that we apply the motion capture data to some skeleton, because people want to animate the character which are much more looking like a humans. So we are going to create a kind of polygon mesh which is called the skin. So this mesh is going to be cover the armature or the skeleton. So when we are moving the skeleton, this armature or the mesh is going to be automatically moved. So this will have some like a clothing, like a shoes, like a socks. So the people will like this thing, that something like a humans, they are moving this thing. But remember that actual motion data is being applied to the skeleton or the armature, and these mesh or this skin is attached to the armature. So when the armature is moving, automatically this mesh is moving. For example, when we are moving our bodies and we are wearing the cloth, so when our bodies are moving, our clothes are automatically moving with us. So the same concept is being applied there. In character animation, directly animating the polygon mesh is too time consuming. As I told you that polygon mesh is attached to the armature, which is basically the skeleton. Armature is animated, which in turn animate the polygon mesh model. So we are performing the animation of this armature, and this skin or the polygon mesh is automatically moving. Now we are going to discuss about the file format which is called the BioVision Hierarchy file format. A company which is called the BioVision, they develop this file format, how we are going to store the motion capture data in a file, and then they make it freely available, so anyone can store the motion data in the BVH file format and we can use this. So this BVH file has the two section. One section is the hierarchy section and other section is the motion section. In the hierarchy section, we have to define that how many bones are there, what are the bones are there for the skeleton. For example, here we say that we have a hip bone or the hip joint, chest, neck, head. So this is like a skeleton. This is like a hierarchy of the skeleton. So this section of the file will consist of this information, hierarchy of the joints or the bones, and what are their initial positions are there, because all the joints are not at the same position. Maybe we have the skeleton in which our hands are like in the T position. So we have to specify that what are the initial position for the hands, what are the initial position for the feet in this hierarchy section. Initially, that you can say that a standing pose is there. And then the second is the motion section, in which we are storing the motion data. As I told you that this data is being stored frame by frame. So for all the joints we have a data for the frame 1, then we have the data for the frame 2 for all the joints, and then frame 3 and frame 4, as I tried to show you here. But in the BioVision file format, we are trying to save some space, so we will do some more thing in the BioVision file format. What we are going to basically do in the BioVision file format, let me try to explain again with you. We are going to define one of the joint as the root joint. So usually this joint is somewhere here, so this is called the root joint. and this is at the highest level, and all the joints are at the lower level. So regarding the translation, that is the motion along the x-axis, y-axis and the z-axis, we are only translating the root joint, and because all the joints are at the lower level of the root, as I told you that when the joint at the higher level is doing some motion, some movement, joints at the lower level are automatically moving with this, the root joint. So when the root joint is performing the translation along the x-axis, y-axis, z-axis, so all the other joints are doing the translation along with the root joint. So by this we do not have to save the translation data for the other joint. We are just going to store the translation data for the root joint. This is in the BVH file we are doing this thing. But regarding the rotation, for every joint we are going to store the rotation data. There is the rotation about the x-axis, theta x, rotation about the y-axis, and theta z, rotation about the z-axis. But the translation is going to be stored only for the root joint, because when the root is translating, moving along the x, y or the z axis, all the joints are moving automatically with the root joint because they are connected. But the rotation can be individual. Maybe root is not moving, but we can rotate the hand like a 30 degree, 40 degree, 50 degree. So this is the thing we are doing in the BVH file format. Let's read further about this thing. Hierarchy describes the joint hierarchy and initial pose of the skeleton. As I told you that this hierarchy section will define what are the joints are there, and which joint is at the higher level and which joint is at the lower level, and what are their initial position is there. Each joint in the hierarchy has the offset field and the channel field. Now what are these fields are there, what are these values are there in the hierarchy section? The offset field stores the initial offset value for each joint with respect to the parent joint. So as I told you that joints are being arranged in a hierarchical structure, so we are not going to store the absolute value for the joint in the BVH file. We are going to store the, let me again discard this thing, again make it bigger. So when we have to store the value for a joint at the lower level, we are going to store this value with respect to the parent. For example, the chest joint is at the lower of the hip, so the value for the chest is being stored with respect to the hip. Maybe initial position for the hip joint is like a 0, 0, 0. Then the chest may be 2 unit is on the x side, so we are going to store here 2, 0, 0, means that x value is being shifted of the chest with respect to the hip 2 units. Y value is not being changed, Z value is not being changed. So we store the value of the chest with respect to the hip. Similarly, we are going to store the value of the neck with respect to the chest. So this is the way the BVH file is storing the value. So the child joint is storing its value with respect to the parent joint, not absolute values are being stored there in the BVH file. So this is the offset field. This is the meaning of the offset. So they are stored with respect to the parent. Notes about the channel. What mean by the channel? The channel field is not written here, but let me try to explain. The channel field is trying to explain that what kind of translation and the rotation a joint can perform. As I told you that in the maximum possibility that a joint can perform the translation along the XYZ axis, and the joint can perform the rotation about the X, Y and the Z axis. So maximum possible degree of freedom is a 6, but it will not happen because I told you that only the root joint will have the translation values. If I say that, for example, this is the root and the rotation value, but the other joint they will not have the translation value, they will have only the rotation value, because when the root is moving, the remaining joints are moving automatically with the root. So in the BVH file format, the root joint will have all the 6 degree of freedom, translation 3 translation values and 3 rotation value, total 6. So 6 degree of freedom is there for the root joint, but the other joint usually they have the 3 or 2 degree of freedom, only the rotation. So this will be the case for the other joint. So similarly we have to store the values for the other joint like the same format. So this is going to be in the BVH file format. So we will do the same thing here. Other joint will have only the rotation value. Similar thing will happen for the frame 2, frame 3, frame 4 and up to the frame n. Now this is the shown there. This is the BVH file format. I will try to open you this file in some other program so you can see that how it look like this. Let me discard this thing. So here I have this folder in which we have the BVH file, and this file name is the ladder to BVH. When you download the lecture, you will find also the BVH file. So let me open this file. Let me open with, no, it's better that I open the editor, which is this one, and I open the new file here, and I drag and drop there this file ladder.02 BVH. So this is the BVH file is there. Let me make it little bigger so you can see that this is the file. We have the hierarchy section is there. Let me make it smaller. No, this is continue the hierarchy section. So when the hierarchy section will finish, there will be a motion section. So I told you two sections are there in the BVH file. One is the hierarchy section, which defines the hierarchy and the initial position, and the second one is the motion section, which is describing the motion data. So this is the BVH file, and as you can see that this is like a text file. So but this contains the data about the hierarchy and the motion. So here we define the hierarchy of the joint. At the top level we have a root joint, and in this case this is the hip joint. So all the joints are connected to the hip, and the offset position for the hip joint is 0 0 0. So you can say that the hip joint is at the origin, and this hip joint has the 6 degree of freedom or the 6 channel. So the degree of freedom and the channels, they are the same thing. 6 means 3 translation value, translation along the x-axis, y-axis and the z-axis, and 3 rotation value. So these are the translation along the x-axis, y-axis, z-axis, and these are the rotation, z rotation, x rotation, y rotation. So this is for the hip joint. Now the joint which is at the lower of the hip is called the left hip, and this is the offset position, the relative position of the left hip with respect to the parent, that is with the respect to the hip. So you can see that the x value is changing from 0 to the 3.5, y and the z values are not changing. So initial position for the root is 0 0 0, and the left hip is just shifting the x value, y and the z values are not shifting. And now let's see the degree of freedom of the channel for this root joint, left hip joint. So this has a 3 channel, the root has a 6 channel, but the left hip has a 3 channel. It can perform only the rotation, z rotation, x rotation and the y rotation, which I try to show you here in this file. Sorry, here, maybe here, yes. So the root joint has the 3 translation and the 3 rotation value. Other joints will have only the rotation value, 3 degree of freedom or the 3 channels. Sorry, again I have to come here. So this is the left hip joint. Then the lower of the left hip is the left knee, and you can see that we are increasing the indentation. Initially we have the root hip, then the left hip is some indentation. Indentation is increasing for the left knee. So now we are storing the initial position for the left knee with respect to the left hip, because the parent of the left knee is the left hip. So x position is 0 with respect to this one, 3.5. Y position is minus 19, so we have to move minus 19 on the left side, and the z value is not changing. So this will keep on continue. We have the left hip, left knee, left heel, and then finally the foot, which is called the end side. Because I told you that the humans have a symmetric structure, so we have the hip at the highest level. Then because we have the left hip, we will also have the right hip, and they are at the same level. So you can see the left hip and the line is coming here, and the right hip is there at the same level. So we have the hierarchy for the right hip, offset position, then we have the right knee, then we have the right heel, then we have the end side, then we have the other joints are there. So this is the hierarchical sections. There we are storing the hierarchy and we are storing the initial position. Now the second thing is that, let me turn this thing as word wrap is off, the motion data. So the motion data consists of the 153 frame. For every frame we are going to store the values for every joint. For example, here we say that the root joint has the 6 values are there, 3 translation and 3 rotation. So in this motion section, the first 6 values are there for the root joint. 1, 2, 3, 4, 5, 6. So these 6 values are there for the root join in the frame number 1. This is the frame 1. Then after the root joint we have the left knee, and this has the 3 degree of freedom. So after the root joint, so after the 6 values 1, 2, 3, 4, 5, 6, these are the 6 for the root. The next 3 values are for the left hip, 1, 2, 3. So this will continue. Here you can see, let me move it this bit here. You can see this is a big line because this is storing the value for all the joints. So this will continue on the right side. So you can see if I am just scrolling. So this is the long line. This whole line is storing the values for all the joints for the frame number 1. So we have a frame 1, and as I told you that 6 values for the root, then the 3 value for the left hip, then the 3 values are there for the left knee, then the 3 values are for the left heel, then so on and so forth, and until the right side is coming. So we have the frame number 1, then second line is the frame number 2 for the motion data, then frame number 3, and until we have the 153 frames are there. So this part is the hierarchy section, and the next part is the motion section, in which we are recording the movement of the joint. So this whole is the motion section. So this is very small file. This is just like a 160 frame. So if we say that we are recording like a 30 frame per second, so 153 frame is something like a 5-second movie is there. This is like a 5-second animation because 153. So maybe the recording rate is 0.033, means that if you divide it by 1 over 0.033, let me open the calculator. So if I do this thing 1 divide by this value, so this is going to give me that this is like a 30 frame per second. So in 1 second we are recording the 30 frame. So second one 30 frame, second two 30 frame. So we are recording for the 5-second, around 5-second video is there, animation is there. So this is, in this slide we are trying to explain you the same thing. We have the hierarchy section, and then we have the motion section, which I try to explain you that here this is written some other from some other file, 994 frames are there, and then the motion data is there. This lecture was a small lecture, only 15 slides are there, but I tried to explain you. Now I uploaded some software there. When you download the lecture, you will find that there is a software there which is the motion view. So you are going to open this software, you are going to double click, and let me make it bigger. In this software, then you are going to go to the option file, open the BVH file. There are the many kind of motion files are there, acclaim files are there, other files are there, but we are interested on the only in the BVH file. So open the BVH file. 3 files I gave you, they are already available on the lecture slide. For example, ladder2.bvh, I open this file, I press the button OK. So you can see some skeleton is there. I can press the button play. So this skeleton is using the motion data from the BVH file, and they are climbing the ladder. So this is being repeated there. So if you choose some option like effect markers, joint lines, and joint ellipsoid, so you can better see these options are there, like many options are there. So this is being repeated. We are having 153 frames are run, as you see that there was 153 frames are there, and this person is using the motion data to perform the movement. You can use the mouse to see with the different angles. So I'm just pressing the left mouse button, and I am showing you with a different angle with this thing. So you can use this software to see how the BVH files are. You can download the BVH file from many websites, and you can play in this software. This is a very basic software written in the C language. Professional softwares are like a Blender, Maya, Motion Builder, in which you can create your own characters which have the human-like shape, and then you can apply the motion capture data BVH file to these characters. Then your animation will be much more natural looking animation. And also you can press, I think you can press the middle mouse button to make it closer. So middle mouse button I am pressing to do this thing. Similarly, you can go to the file, open the BVH. You can try with the second BVH file, thief, and press this button. So this is moving like a thief. So you can open the BVH file, and you can see that this person is moving like a thief. Similarly, I can go to the file BVH, and I come to the walking high, and this person is showing the walking high style movement. So this is how the motion capture data is being applied to this character. As I told you that this is the basic software. You will find that the software is available, motion view, exe file, and the 3 BVH files are there. You can open the BVH file in many software. I open in the edit pad plus plus. You can also open this file in the notepad. For example, this is more application. So if I choose the notepad, you can open this file. So BVH file is just like a simple text files are there, but these two sections are important: hierarchy section and the motion section. Motion section contains the data which the software is using to run the animation. If you are more interested, then you have to use the software to create the characters and to control this motion. I told you the name of some of the softwares are like a Blender, which is a free, motion builder. I use this software, motion builder, very good software, easy, not very difficult. But I think that this might be available for student for the trial version. And the Maya, these are the professional softwares are there, so you can manipulate the motion data and you can create the characters, and you can run the animation. So this is our lecture about the motion capture. Please give me the feedback about this lecture. I am using the software, and I will try to record all the lecture by this. So read the lecture slide is very important. I will give you also the assignment, and which will ask you the question about the lecture. So I try to know that you are listening the lecture and you are reading the lecture slide. Okay, thank you.